Oh, it's 1:30. Okay. Anyway, let's take this.
All right. Hello, everyone. So it's 1:30. So we're going to get started. Just to make sure we're all at the right place, this is block T8, and we're on our fourth talk now. This is Arduino Tutorial for Beginners by Caitlin Frolio. Whenever you're ready.
All right. Hello, everyone. My name is Caitlin Frolio. It is a beginner's guide to Arduino and programming. This is usually a 3-hour, 4-hour hands-on workshop at TCF. This time I'm just trying to cover all the theories, maybe go through a little bit of coding. I'm not sure how much I'm gonna be able to cover in 1 hour. So the topics I'm gonna cover are the hardware, Ohm's Law, basic electronic components that we usually use with the Arduino, the difference between analog, digital, pulse width modulation. We're gonna talk a little bit about the programming, Arduino programming, the IDE setup, functions. I'm not gonna go into too much detail about how to write the code, but I wanna everybody have some basic idea how to get started. We're gonna do some circuit examples like blinking an LED, feeding, showing pulse width modulations, maybe color mixing and serial communication. I'm not sure how many people actually have an Arduino at hand or plugged in. Maybe you can follow along. I'm gonna go step by step. So, oh, and again, I forgot to introduce myself. I work as a radar engineer at Lockheed Martin. I did my undergrad at TCNJ. Actually, Dr. Katz was one of my professors. And I just finished grad school a year ago, yes, at Villanova. So that's my background. So what exactly is an Arduino? Arduino is basically a tiny computer that we can program. What I like about it, that it's open source, both the hardware and the software. Oh, next slide. So it's available. You can just Google Arduino and you're gonna find a lot of code, and the IDE, when you download it, it's gonna come with a lot of examples. So you don't have to worry about writing the code. You can just play around with those. So basically the heart of the Arduino is the microprocessor, oscillator, regulator, and the USB connector. The next slide shows all the pinout of the Arduino, but you don't really have to know every pin. You really just have to be aware that the digital pins, there are 14, 0 to 13 digital pins. Six of them are pulse width modulated, which I'm gonna explain later what that means. And you really wanna know the analog pins, which is 0 to 5, 6 of them. And you wanna know where the ground is, and 5 volt, 3 volt supply. And you wanna know how to connect to your computer with a USB jack. So you have usually when you buy your Arduino, it comes with a serial cable, and you can connect it to your computer to upload your sketches or code, whatever you want to call it. Next slide. So there are many boards. Like I said, they are open. Hardware and software are open source. That means you don't really have to go to the Arduino website to buy the original one. Although I had better success with the boards from the website with the Mac, the other ones are really not compatible with, where's the website? Okay, so this is the Arduino website where you can download the IDE and you can buy hardware from them. They have many boards and they have some starter kits. They tend to be a little bit more expensive than what you can find on Amazon. I usually buy this, I usually buy a starter kit from Amazon or eBay when you can buy something for, I don't know, $16, $20. That comes with a breadboard, with a board itself, with the cables, resistors. I prefer that one. But like I said, some of those are really not compatible with the Mac computers. So I would check on those. So this is some basic specifications. So the input voltage is between 7 and 12 volts. So if you want to power it with a battery, you want to make sure you don't exceed, 6, maximum 20 volts. But if you connect it with your serial cable to your laptop, that's going to power it, which is going to give it 5 volts. So that's good enough. But if you don't have a laptop or a computer, you can always use a power cord. You can connect it to a battery. So there are, like I said, there are 14 digital pins, 6 of them pulse width modulated, 6 analog pins. The current you have is around 40, the 5 volt is 40 milliamp. We're gonna talk about it all, how we calculate current and everything. The other stuff, it has enough memory. We're not writing, 10 pages of code. We're just gonna do some blinking, some simple stuff. So you don't need that much memory. So now we're going into the theory part. I'm not sure how many people know what voltage, current, resistance, pulse width modulation means. So I usually like to cover this before we go to the hands-on, which this time gonna be tough. So voltage, basically, I like to use this example of a water tank because it's really hard to explain what current voltage is because we really can't see charges moving around. So voltage, basically a potential difference between 2 points in a circuit. So you have to have a potential difference to have the current moving. So you can light up an LED, for example. And here in this picture, we can see for the water to flow, you have to have some potential, and that would be the water flowing would be the current. So the symbol for voltage is V, and it was named after Italian physicist Alessandro Volta, and the units are the volt, 2 volts. And the next one is current. So when you look at these 2 different water tanks, you can see that they have same potential, but different amount of current, water in this case, going to flow through, because on the next slide, going to talk about resistance, because one has more resistance, the other has less. So the symbol for current is I, and the units are amperes. The next, I already touched on resistance. As you can see, one tube has less resistance, so more voltage, current will flow through. The other one has less. And the next one is Ohm's Law. So we talked about voltage, which is units in volts, current in amps, and resistance in ohms. So this explains the relationship between these 3. So if you know 2 of them, you have voltage and resistance, the voltage and resistance values, you can always calculate the current. So voltage equals I times R, I equals V over R. This is a little cheat sheet. So you can just look at this triangle and see how you calculate it. It's pretty simple math. I'm not sure. Hopefully nobody has questions. Just let me know if there are questions. So for example, in this tank, we can see the potential is 1 volt and the current is 1 amps. So if we only know these 2, you can calculate the resistance, which is going to be 1 ohms. So for example, if you have 1 in the other one, you have 1 volt, 0.5 amps, you go back to the formula, 1 ohm, 0.5 amps, you can calculate I, which is V over R. It's gonna be 2 ohms. I think that's pretty simple, right? So next we're gonna talk about the basic components we're using when we working with the Arduino. A lot of people don't understand how the breadboard works. So this is a picture of the breadboard, and you see these lines, the green lines are connected. Basically, there's a piece of wire under it. You see the blue and the red, that's all connected. So this makes it easier to put your little resistors there and your LEDs, and you use some jumper wires. So basically you can build a little circuit in 2 seconds instead of trying to solder stuff and use some jumper wires. So, and you just break it down your circuit and you build another one. Like I said, some starter sets come with breadboards, LEDs, resistors, and even some jumper wires, which makes it really easy to build a circuit. I'm not sure if anybody's seen resistors before. This is some surface mount, and these are the symbol for resistors. They're usually color coded. Next one. During the hands-on workshop, like I said, we usually grab a resistor and spend 15 minutes trying to figure out what the value is. Then we use a multimeter and check it against our guess. So this is usually a fun activity, but this time is not as much fun trying to explain it, just looking at it. Like you said, you can see there are different bands, 4, 5, 6 bands, and each color represents a number. So the 5 band, the yellow one is 4, purple 7, the green is 5, and the red one gets tricky. That's a multiplier, which means you multiply by 100. And the last line is usually the tolerance, which means it can be plus minus, this time is brown, 1%. So the value can be plus minus 1%. In this case, is 47.5 kilo ohm resistor, can be a little bit more, a little bit less. It's very hard to build a resistor exactly that value. So unfortunately, we cannot test this out, but I usually give everybody one resistor, we measure it and try to guess the value. We also use LEDs. We're gonna have an example, a blinking example. So LED stands for light emitting diode. So the one important thing you have to remember, LED, it's basically a one-way street. So you have to, if you hook it up backwards, your circuit not going to work. So what we try to remember in this picture, the LED picture, you can see there's a negative, a cathode, and a positive leg. You see one of them smaller? So the negative always goes to ground. So to have a closed circuit, you have to have a voltage source and ground. So it has to, the current can flow. So if you accidentally, you're not gonna do damage. If you plug the positive to ground, it's just not gonna turn on. So that's one thing we try to remember is put the LED, the short leg to ground. And of course, with the breadboard, we use wires. It's usually just a simple 22 gauge wire we use, and some of them can be stripped, or we can just strip it with a wire stripper. I wouldn't use fingernail. The slide says fingernails, but I wouldn't do that. Maybe with a knife or why.
Hello, Caitlin. Can't hear you.